Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and this short video is going to deal with the calculation of type 2 probabilities. And type 2 probabilities we are defining as probabilities where we have to calculate the probability of a z-score being greater than a particular positive value. Okay, so let's just plot this on a curve, the standard normal curve, because we're dealing with the standard normal variable z. And this type of probability is a probability where we have to calculate the probability or the area to the right hand side of a particular positive value. So we have the standard normal curve that's centered on 0. The horizontal axis represents our z-scores or the z variable, and this type 2 probability is with respect to a positive bound. So let's say we have x1 here, and we're interested in the probability of observing a z-score that's greater than x1, and all the z-scores greater than x1 are on the right hand side of x1. So this type of probability is asking us, can you tell me what the area is to the right hand side of x1, or can we calculate the area in a right hand tail? Okay, brilliant. Okay, so let's have a look at an example. In this situation, let's say we want to calculate the probability of observing a z-score that's greater than 1.53. Okay, the first thing we do when we're given a particular probability statement like this, with respect to the standard normal variable z, we draw the distribution. Okay, so the distribution is a bell-shaped curve. It's centered on 0. The horizontal axis represents our z variable, and 1.53 is a positive value, and it's on the right hand side of 0, so 1.53 is here. Now, like the definition over here, we're interested in z values that are greater than 1.53, so we're interested in the calculation of the area on the right hand side of 1.53. Okay. So anytime you have a positive z value, the first thing we should always do is we should look that particular z value up in our tables. Okay, so don't forget the first significant digit and the first decimal digit is listed down the first column. In this case, we will be looking for 1.50. And the second decimal digit is listed across the first row. In this case, the second decimal digit is 3. So we'll be looking for 0.03. So when we go to our tables, what we will do is we'll triangulate across from 1.50 and down from 0.03. So when we do that, we come down to 1.50. We come across to the column 0.03, and what we have is a value of 0.9370. So this is 0.9370. Now what we know is that for our tables, that when we look up a positive value, okay, 1.53 in this case, we are always presented from the tables with the area to the left hand side of that positive value. In our case, the area under the curve to the left hand side of 1.53 is 0.9370. Okay, now we're not interested in the area to the left, we're interested in the area to the right. Okay, but let's remember one of the properties of the standard normal distribution, and that property is that the total area under the curve, bounded by the curve and this horizontal z-axis, that the total area is 1 unit. So what we know is that the area under the curve out to positive infinity and negative infinity is 1 unit. Okay. Now hopefully what we can see is that if we take the shorter line away from the longer line, what we're left with is the portion of the line that's pointing in the negative direction. So really, the area to the right hand side of 1.53 is the longer line minus the shorter line, which is 0.9370, which is going to give us a value of, well, let's do that on the calculator. Okay, it is 1 minus 0.9370 gives us a value of 0.063. Okay, so in other words, what we have is the probability of observing a z-score that's greater than 1.53 is equal to 0.063. Now, like all of our other probabilities, what we could also do is we could convert this to a percentage. We convert a decimal to a percentage by multiplying by 100. So we can see that this is approximately equal to 6.3%. In other words, the likelihood of observing a z-score greater than 1.53 is you're going to see a z-score greater than 1.53 about 6.3% of the time. Or the probability of observing a z-score greater than 1.53 is equal to 0.063. Okay guys, that concludes this particular short video on how to calculate type 2 probabilities. Their probabilities associate with z values being greater than positive values, and they're right-hand tail probabilities. And one thing to keep in mind here is this is a quick rule for us that anytime you want to calculate an area in a tail, you always have to take away from 1. Okay, let's say that once more. Anytime you have to calculate an area in a tail, we'll always take away from 1. Okay guys, thank you very much. My name is Jonathan Lambert at the Mathematics Development and Support Service at the National College of Ireland. And I suppose stay tuned for the next short video which deals with our type 3 probabilities. Okay, thank you.